Alright, today we're going to look at some theorems or rules that can help us find the zeros, the rational zeros and the real zeros of a polynomial. Keep in mind a polynomial cannot have more real zeros than its degree. So whatever its degree is going to be the most that it can have. It can have fewer than that, but not more. When the coefficients of a polynomial are integers, so that means positive, negative numbers, no fractions, no decimals, then we can use the rational zero theorem to give us a list of possible zeros. So how do we do that? Well, if we look at the theorem, it's right here, and it says that we take the factors of our constant, so the factors of our term without a variable, and we divide that by the factors of our leading coefficient. And that's going to give us the possible rational zeros. So if we look at this example here, our constant's -6. So what are the factors of -6? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And then our leading coefficient is 1. So what are the factors of 1? Plus or minus 1. So that's kind of an easy one. So if we're looking at our constant factors divided by our leading coefficient. So 1 divided by 1 and -1 divided by 1 is just going to be 1. So plus or minus 1. Positive 2 or negative 2 divided by 1 is going to be positive 2 or negative 2. So plus or minus 2. Positive 3 or negative 3 divided by 1 is going to be plus or minus 3, and the same thing with 6. Now, that was because we were dividing by 1, and that's simple. And now, how do we find out if these are zeros? Because right now, we have 8 possible zeros, but we know from our degree that the most we're going to have is 4, because that's what that degree is, degree of 4. So how can we tell? Well, we have some options. We can just plug it in and see if we get a 0. Plug into our polynomial. You could also do division. You divide and see if you get a 0 remainder. Now, the easiest thing to do here would be to just plug them into the function. So if I plug 1 in, what do I get? Well, you plug a 1 in, 1 to the 4th, minus 1 to the 3rd, minus 5 times 1 squared, minus 1 minus 6 ends up giving us a -12. Plug in a -1, and you get a -8. Plug in 2, and you get a -20. Plug in -2, and you get 0. So there's 1. There's 1 0. Plug in a positive 3, and you get 0. There's another 0, so there's 2. Plug in a -3, and we get 60. Plug in 6, and we get 888. And plug in -6, and we get 1,332. So we had 2 that gave us zeros. Now, how do we know we didn't accidentally make a mistake and miss something? Or how do we know that we have all that we should? Also, what we're going to see later on the back is how can we maybe limit which ones we're checking. Well, what we can do is use Descartes' rule of signs. And what that says is if you look at the original polynomial and you look for sign changes from positive to negative to the next term, if that whatever your amount of sign changes will tell you how many positive rational solutions you have. So it's either that amount or an even number less than that. So what does that mean? Let's say I looked at it and let's say I had 7 changes. Let's say there was 7 changes. That means I could have 7, 5, or 3, or 1 positive zeros. Let's say I had 4 changes. And that means I could have 4, 2, or 0. 0 is not any positive. So however many times my sign changes, that's how many possible, or how many positive roots I'm going to get. Now, to find out how many negative roots, so how many negative, I plug in a negative x to my polynomial and then do the same thing and look for changes. So if I plug in a negative x and have 7 changes, then I would have 7, 5, 3, or 1 negative zeros. So if I'm just looking at the function itself, that would be my positives. If I plug in a negative and look at the changes, that would be my negatives. So looking at this function, the one we were just doing above, I'm going to just take a peek and rewrite it and see if I'm seeing any sign changes. So it's changing from positive to negative. So positive to negative, that's 1. Negative to positive, that's 2. Positive to negative, that's 3. So this has 3 changes. The polynomial itself. So that means it could have 3 or 1 positive zeros. Which, if we think to what we did up above, when we plugged it in, we had 1 positive 0 right there. So you can have 3 or 1. We did have 1. Now, if I replace x with a negative x, so that would be x to the 4th when I plug that in, that would be plus 2x to the 3rd, because if I plug in a negative for a cube, that means it would be negative, but I already had a negative out there, plus x squared, because if you plug in an x, a negative x to x squared, it stays positive, minus 2x, because if I plug in a negative here, that's going to make that a negative, and a minus 2. And looking for sign changes, I see 1 here. There's only 1. So that means there's 1 negative 0. And if I look up above where I plugged them in, I did have 1 negative 0. So I found my positive rational solution and a negative one. Now, the 2 theorems we looked at in the front, the rational zero theorem gives us our possible rational zeros. And then the Descartes' rule of signs gives us our possible combination of positive and negative real zeros. We can also use something called the upper and lower bound rules. So this rule tells us what, if something is an upper bounding that we can't have solutions above that, or if it's a lower bound saying that we can't have solutions below that. So looking at this rule, if I do synthetic division, which is what I need to do, and my bottom row, or my quotient, is all positive or 0, then that value that I divided by is an upper bound. And if I do synthetic division and my rows are alternating positive or negative, then that is a lower bound. So this example right here is going to show you what we're talking about. If we think about the factors, it's plus or minus 1, plus or minus 2, or not factors, sorry, the zeros. Plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. So there's all that we have. That's 1, 2, 3, 4, 5, 6, 12. 12 possible zeros. Now, I'm telling you, because I've already done this, that it's bounded between negative 4 and 4. So that will shorten my list of things that I need to check. So let's just take a look at this. If I synthetically divide by negative 4, 1, 0, negative 5, negative 10, 12, negative 20. Bring that down. That's a negative 4. And that's going to be negative 4. That'll be 16. That will be 11. Negative 44. Negative 54. Multiply that. And I get 216, so that will be 228, multiply that, and I get negative 912, can see these are alternating, positive, negative, positive, negative, positive, negative. That means this is a lower bound. That means I will not have zeros below -4. So -5 won't be 1, -10 won't be 1, -20, and actually -4 either, because that would have been 0 if that was a 0. Now I'm going to check that upper bound, which was 4. Do the same thing, synthetic division. 1, 0, -5, -10, 12, 20. Break down that 1. 4 times 1 is 4. Add those, that's 4. 4 times 4 is 16. That's 11. Multiply those, that's 44. 34. Multiply that. And I get 136. Add those up, and I get 148. Multiply 4 by 148, and I get 592. Add those, I get 572. So, this was all positive. This whole row is positive. So what does that mean? That means that 4 is an upper bound, which means no zeros above that would be 0, or no possible zeros would be zeros. And because this is not 0, 4 is also not 1. So if I look at what that eliminates this one, this one, this one, and this one. So I don't have to check for values. So that's just something that allows you to minimize the amount of work you have to do at checking to see which of these are zeros. Now let's put it all together. Let's do a problem top to bottom using everything. So if I'm starting this problem, I'm going to start by figuring out what my possible zeros could be. Possible, remember rational, could be irrational. I can't figure that out. So factors of -9, and what are they? Plus or minus 1, plus or minus 3, plus or minus 9. And factors of 4 are different. We've got 1 most vertical. Plus or minus 1, plus or minus 2, plus or minus 4. So now remember, we are doing factors of the constant divided by factors of the leading coefficient. So we have to do each one. I'm going to start here with 1. 1 divided by 1 is plus or minus 1. 1 divided by 2 is plus or minus 1/2. 1 divided by 4 is plus or minus 1/4. Then I'm going to do 3 and divide it by each one of the factors of the leading coefficient. So I'm going to have plus or minus 3. Plus or minus 3/2. And then plus or minus 3/4. Then I'm going to take 9. Divided by the factors of the leading coefficient. So you get plus or minus 9, because 9 divided by 1. Plus or minus 9/2. And then plus or minus 9. So right there, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 18 possible zeros. We would not want to plug all of those in and see if they're 0. But you can. So let's see if we can help eliminate some. So let's look at Descartes, and we'll look at our original function and see how many sign changes there are. So looking at sign changes, here to here, positive to negative. Then I have here to here, negative to positive. Then I have positive to negative. That's 3 changes. So that's 3 or 1 positive. That doesn't really help me, because I have 18. And 9 of them are positive, and I can't eliminate any from them. So then I'm going to check by plugging in negative x. That'll be negative 4x to the third minus x squared minus 36x. Sign changes. I have none. So I have 0, 0, negative zeros. So what does that mean? That means I cut everything in half. Now I have only 9 possible zeros, because it has to be positive, no negatives. So what do I have? I have 1, 1/2, 1/4, 3, 3/2, 3/4, 9, 9/2, 9/4. I'm going to see if I can find a boundary. I'm going to go with 1. I'll start with 1. If I eliminate everything below it, that's a couple that I can eliminate, so if it's a lower bound. Or if I eliminate everything above it, then that's also quite a few. So I'm going to go with 1. 4, negative 1, 36, and negative 9. Write down that 4. 4 times 1 is 4, so 3. 3 times 1 is 3, 39. And then 1 times 39 is 39, that's 7. So, that's all positive, which means that's an upper bound. So anything greater than 1 is not going to be a solution. So what can I eliminate? Things greater than 1, 3. 3 halves, 9. 9 halves, 9 fourths. Also eliminate 1, because it's non-zero. So now I only have 3 possibilities, half, 1/4, and 3/4. Now I could check any of those and see if it's an upper bound, but here's the issue. 3/4 is not a 0, and it's also, and it's an upper bound, then I'm going to have to check 1/2, and so on. So I'm going to go with the smallest one. I'm going to check 1/4, see how that turns out. 4, negative 1, 36, negative 9. Write down that 4, 1/4 times 4 is 1, multiply 0, 1/4 times 0 is 0, that's 36. 1/4 times 36 is 9, then put in 0. So, this whole row is positive, which means it's an upper bound, which means nothing higher than it can be a 0. So that eliminates 1/2 and 3/4, because those are both bigger than 1/4. Something else I noticed right here. That is 0 remainder, which means 1/4 is a 0. In fact, the only one there. So notice though that it says that we know that it's next to thirds, that means we have 3 possible roots. But you say, well, we only have 1, the other ones could be complex. So keep in mind a little bit.